For number 12, we first find f of 2, so we go to the f equation. Wherever we see x, we insert 2. So we do order of operations. 2 squared was 4, and then 4 times 3 gets us 12, and 12 plus 1 gets us 13. So 13 then goes in this slot, right? So we get p of 13. It's a bunch of substitution. So now we go to the p equation and plug in 13 wherever we see x. So if the p equation was x plus 2, in the x slot we plug in 13, and 13 plus 2 is 15. So 15 is your final answer. P of f of 2 is 15. For this next one, we first work inside out. So we go and grab the right side of m of x, which is 5x. We insert that here. We then go to the g function, and if the g function was x squared plus 4, wherever we see x, we put parentheses. We then insert the quantity 5x wherever we see x. Remember, insert in parentheses. So 5x squared is 5x times 5x, which is 25x squared, and then we have the plus 4. Domain restrictions, inside out. Are there any restrictions on m of x? No. There's no radical with even index, no x in the denominator. Then are there any restrictions on final answer? No. Therefore, the domain is all real numbers. For number 14, it says, what's the domain of y equals, or f of x equals 1 over 3x plus 5. Red flag goes up if we have a radical with an even index, 2, 4, 6, so on and so forth, or x in the denominator. So if you set your denominator equal to 0 and solve, that's your target. So our target is negative 5/3. Make a number line, always put your target on the number line, and when you plug in negative 5/3 into the x slot of your equation, the 3's cancel, so you'd have negative 5 plus 5 in the bottom, which is 0, and 1 over 0 is air. Therefore, it's an open circle because you cannot plug in negative 5/3. If you plug in 0 or any number on the right, you'll get out a number as an answer. So if I plugged in 0 for x, 3 times 0 is 0, plus 5 is 5, so we get 1/5, check, we get an answer. If I plug in any number to the left of negative 5/3, like negative 2, it also works. 1 over 3 times negative 2 plus 5 would be 1 over negative 6 plus 5, which is 1 over negative 1. As long as we don't get error, check, we get solutions. So the only restriction is we can't have negative 5/3 in our table for x. So the domain is all reals, but x cannot be negative 5/3. Lastly, for this last problem, we see a radical with an even index. And remember, you could also see this as 2x to the 1/4. When you have powers that are fractions, those are radicals in disguise. So you rewrite that part as 4th root of x to the 1st. If you have a radical, which we do with an even index, you set what's under the radical equal to 0. That's our target on the number line. When we plug in our target, we plug in 0 for x. The 4th root of 0 is 0, and 0 times 2, the number in front, is 0. Check, that works. We get an answer. So we circle 0 because you are now allowed to plug in 0. If we plug in a number bigger, any number, like 16, if you plug in 16 for x, the 4th root of 16 is 2. So then 2 times the number in front, 2, would get us 4. Check, that would get us an answer, so we shade on the right. If we plug in a number on the left, like negative 16, the 4th root of negative 16 will say error. There's no real value, so we don't shade anything on the left-hand side. Therefore, look at this inequality. On the x-axis, our circle starts at 0. It's closed. We shade to the right, so we say x has to be greater than or equal to because of the closed circle, 0. So all reals, x greater or equal to 0.